Okay everyone, a student asked me how to do tracks on a tank, and I'm going to run through a quick way to do that. Um, Another tutorial I'm going to put up is on path deform, but this one's going to be on a splineIK solver is what it's called. The difference between these two is that a splineIK solver will work on rigid objects and it will just rotate them and try and solve the actual shape based on a spline rather than actually bend the mesh itself. And this is important for tank tracks, obviously, because tank tracks are not flexible. So I've got this thing mocked up real quick. It's a one piece of track that sort of fits together if you repeat it. It's like a little jigsaw. So there's a hinge here, right? For those who don't know about how tank tracks work, there's like a hinge that a pin would just run straight through the middle of these, right? And hinge them together. So we're setting up the hinge by picking our pivot point. Okay, so the pivot point is right there where the hinge would be, and the way we edit that, of course, is under this hierarchy. We go to effect pivot only, and we can move it to anywhere, but we want it to be where the actual track is going to hinge from, or close enough to it. It doesn't have to be 100% perfect. Anyway, we've got our wheels, and the track's going to sort of like drape its way along the wheels a little bit, and we'll put some sag in it for some, for believability, I suppose. So the thing we're going to do first is I'm going to just grab one of these and just expand it a little bit. I'll explain why in a sec. What I'm going to do is, I'll keep that in the element. I've just made a little bigger version of these wheels because I'm going to use the outsides of these wheels as guides for drawing the spline to where this is going to go over. And the thing is, if I draw it right on the edge of the wheel, because of where the pivot point is, it will sit with the center of this, the flat part of this track on the center, on the actual surface of the wheel. So half of it will be underneath the wheel. So I'm just going to pop these out a little bit, right? Just make sure that it's not too much, just enough to see that surface is where the actual wheel is. So I'm going to pop it out maybe that much, and then I'll delete these after, of course. We'll go to our line tool, turn on the snaps. This should be on 2.5D ideally, and I want vertex on because I want to snap to these vertices. Okay, so 2.5D means as we're going around and creating these this spline, like I said before, I'm putting a little bit of sag in this because tank tracks don't in real life completely adhere perfectly to the outside of surfaces or go completely taut. Anyway, what the 2.5 will do is it will give us like it won't give us any depth snapping relative to our view. If we're using the snap in an orthogonal view, it will just keep it on the one plane. Whereas if we had it on 3D, I'll show you what it does. The difference between these two. If I start snapping this on, although it might not be a big problem in this one, but like you can see, not quite. I'll go to different points maybe. If I was going to different points, like with the 3D on, you can see in the top view, it's wonky. It's not flat. So that's the difference between 2.5D and 3D snaps. Anyway, that's kind of a tangent. But we've got our spline here, which is kind of draped around the sort of the shape we want from this tank track. So I'm going to delete that expanded version of the wheel I made as a guide. So as you can see, this spline is just sitting a little bit over the top of these wheels, which is pretty much exactly what we want. So turn the snaps off. I'm just going to move this into the middle of these tracks, these wheels, sorry. Anyway, the next part we got to do is we got to clone these into a long strip of treads. So I'm going to just make a copy of it down here. I'll go copy for now, I guess. And then we're going to use the array tool. If you don't know how to use that, you're about to find out. It's pretty cool. Okay, so we've got our array thingy open. This is a dialog where we can just duplicate an object however many times we want and apply certain transforms to it each time it gets duplicated. So we'll zoom out a little bit. Actually, we'll start zoomed in because we want these to connect up nicely. So we're going to set it to copy. Instance is probably better actually, because then if we wanted to edit the tracks later, we'd have that all be instanced. So we've got incremental and totals. We're going to go incremental first, and we're going to go 2 as our count, I suppose. and then turn on the preview, right? So it's going to give us 2 copies of this track. So we'll start going up on the x-axis until we've got it locked in pretty much where we want it, okay, which is about there. If we were going to go and change the y, it would slide it that direction. We don't want that to change. Same with the z, that goes up and down. We don't want that. The other thing you can do with the array tool is you can rotate in any axis, of course. We don't actually need any rotation in it, so we're going to just 0 those again. Anyway, now that we've got the distance set right for it to be linked up, we can just increase the count and it will just keep copying it, right? And if we were using any of the rotation stuff, that would happen. It continues to rotate it again and again each time it copies it, or it continues to apply this same transform as many times as we want. So we'll go up to 20, I guess. That'll do. Then go OK. Now what we're going to do is we're going to parent all these tracks to each other. We're going to make them attached as far as the engine, the 3ds Max is concerned. So we're going to go to select and link, okay? And what this does is, if you haven't used it, is you click on one object, hold, drag it to the next one that you want to link it to, and now those 2 are linked. See how it flashed with the little bounding box there? If we get a move now, sorry, the other way around. If we pick this guy, it moves with him. So this thing is the dad of that thing. Anywhere that goes, it'll go. So we're just going to do that with everything in this whole chain, which is a little bit of a tedious process, but it's not so bad, I guess. So we're just going click, hold, drag to the next one, to the next one, to the next one with this select and link tool. You can unlink things with the unlink tool as well, all that kind of stuff. But yeah, you have to link these all together, otherwise it's not going to know how to treat them as a chain. So now they're all linked together, right? What we're going to do is we're going to apply on the parent, go into animation, IK solvers, splineIK solver, okay? What that's going to do is it's going to give us a little line, and that's telling us we want to know what the other end of the chain is. So we'll go over to this guy, and that's now defined as the other end of the chain. We've still got a line though, because what it wants us to do is pick the spline that it's going to actually use as the controller, right? So we'll pick that, and now we've got that on the spline. It's a little bit too long, I suppose, but you know how it is. That track is now sort of, just going to select all of these. Come on. It's not treating them as if they're in a chain anymore for whatever reason when I double click. But oh man. Yeah, so we've got them. It creates these little helpers as well, which is kind of annoying. But that's attached now to the spline that we created. So you can see why we needed that little offset at the start, just to make sure that this didn't submerge too far into this into the wheel. But it's not the best example in the world, but I'm hoping you guys can do something more interesting with it. You can also make things like chains, or anything that behaves anything like a chain, or like a bunch of linked rigid objects. You can just bind it to a spline in that way, and it'll all be fine. Anyway, I don't really have much more to say about that. I hope it was helpful. Later.